Hi class, welcome to PEP 288 Motor Learning and Performance with me, Elizabeth Harding. We're going to be going over Lab 3. This tutorial is for those of you that had some questions on the results in the discussion section of your assignment. So looking at the assignment, the first thing that you are to do is from our class data, you are going to create your own spreadsheet. So you're going to clean that up, maybe remove any participants that didn't have data in the spreadsheet, any participants that didn't complete the data, etc. You are going to basically create a clean spreadsheet to use for this assignment. And from that, you are going to calculate the means, so the mean of means and the mean of standard deviations for each of those tasks. And you are going to put those into a table in Excel. So looking at the spreadsheet, so this is my cleaned up spreadsheet. I have 53 participants. Which I found out just by using the count function in Excel. And in the class data sheet, I already provided you with the column for mean and standard deviation. So each participant would have a mean and standard deviation for each test. So really, all you needed to do was take the mean of the means, so using equals average, selecting your data, and the standard deviations, so the standard deviation function .s for sample for each one of the tests. Right, so you're going to do that for your stork stand, your bass stick stand, and your inline stand balance tests. And then I went up to the top here and created a table. So you can see I have my mean and standard deviations in this nice little table here. And this sets us up for part 2 of the lab, which was to graph the results of the table using your calculated mean times. So a very simple column chart would suffice. So I'm already set up to do that. So I'm just going to select my headers here as well as my mean data and go to column, and there we go. Okay, done. So a few things to clean this up. Always get rid of that title. It's hideous. The legend, we don't need it. We already know what's going on. And normally I would have you clean up this y-axis here. So you can see I have my 3 tests and then the average time that was spent in each test. So remember, each test capped at 60. So normally I would have you go ahead and cap this value, format the y-axis to end at 60. But we're going to go ahead and add some error bars from our own calculated standard deviations. So I'm going to highlight my data column, my columns of data here, and right click, format data series. We have error bars. I want to display both the positive and the negative directions. I think a cap looks pretty, so I'm going to use that. And we're going to select the custom feature and specify value. So the positive error values are basically our absolute value of standard deviation. So I'm going to select all 3 cells. Now because I've organized it in this way, Excel is going to know to put this standard deviation with this column of data, this standard deviation with this, etc. And we'll do a visual check at the end to make sure that worked out that way. Okay, and so the same for the negative values. And hit OK. And looks good, right? And so you can see, what's that? So we needed a little bit of that white space, maybe not all of it, but go ahead and leave it alone. Don't fuss with it too much. All right, and then let's just do a visual check right here. So the standard deviation for our stork stand and our bass stick stand were pretty close, the difference between 4.28 and 4.07. So the size of these error bars should be fairly similar. And then for the inline stand, we had a standard deviation of 3.2. So we're expecting that the error bar here would be a little smaller than these two, and it is. Right, so that checks out pretty well. So that's just a way to add a sort of a custom error bars that tells a more complete story about what happened during your experiment. Okay, if you were just to use, one standard deviation, it just doesn't necessarily show the variability between participants for each of the tests, like the standard deviations of your own data does. So the last task that you needed to do was to calculate the correlation coefficient between the three balance tests. You were going to, in Excel, we're going to use equals Corel. All right, so if we were to do this by hand, this is the very lengthy and exhausting formula of the correlation coefficient. So basically your n value for me would be 53 for 53 participants times the sum of the products of all of my x and y values. So if I was comparing the bass stick stand and the stork stand, I would maybe denote my bass stick stand as x and my stork stand as y, etc. Minus the sum of all of the x values times the sum of all the y values. Over, and if you look very closely at these formulas, you'll notice something that should be very familiar, which is the standard deviation, the formula for standard deviation. And so standard deviation does in fact play a role in correlation between x and y. But we're not going to do this. We're going to do this right here, using our mean values. Right, so you can see that I've calculated that here. So I went ahead and created some headers, my stork stand and bass stick stand. So I want to see if there's any kind of relationship between these two. Stork stand, inline stand, and the bass stick stand and inline stand. And I've calculated this using equals correlation and selected all of my stork stand means and then all of my bass stick stand means. So I'll go ahead and demonstrate. So equals, so array 1, let's go ahead and select the means, make sure I have all my data of the stork stand, and then comma. Okay. So go back to look at your formula. So see, we have my E3 to E55, comma. That's my array 1, comma, and my bass stick stand. And select all the mean values of that, and enter. And I have my correlation coefficient, or Pearson's correlation coefficient, R value of 0.13488, etc. Right. So I've gone ahead and done that for the other two tests to look at those relationships. And you can see that the highest value, or the highest correlation I have, is between the stork stand and the bass stick stand, but it's still not a very strong correlation. So if you remember from tests and measurements or your general stats class, what does that mean? So a very strong correlation would be plus 1.0. A very strong positive correlation, meaning things are perfect positive, would be plus 1.0, and a perfect negative correlation would be a minus 1.0. No correlation, it would be a value of 0. So anything that's, say, a moderate, within the moderate correlation value would be either a negative 0.5 or a positive 0.5. And it depends, 0.4, 0.5, it just depends on which text you're reading. But I think for simplicity's sake, just look at, say, a halfway point and say, 0.5 might be a moderate correlation. 0.8 would be a relatively strong correlation, and then of course a 1.0 would be a perfect correlation. So our values are very close to 0, which leads me to think that there's not a whole lot of correlation happening between our three balance tests. Okay, so do these results seem normal? Well, looking at some research that was highlighted in your book, Droutsky, I'm not sure how to say that correctly, and Zucato in 1967, we're looking at static balance and dynamic balance. So they did 3 static balance tests and 3 dynamic balance tests. And you can see that the highest correlation is actually between 2 dynamic balance tests, which are the sideward leap and the Bass stepping stone test. Now, between static and balance, really the next highest we have is a 0.26. So that would be a relationship between the sideward leap test and the stork stand test. But still, not a very strong correlation. right? We want at least, a 0.5 to make any kind of inference that something is related to something else. So our results seem pretty consistent with those that have gone before us. So this leads us to the discussion section of the lab. So what does the correlational value describe in terms of the amount of relationship that exists between the 3 balance tests? So essentially what I would like to know was, were these 3 tests of static balance related? And looking at our correlation coefficients, I would say not so much. Right? And then the next thing that you need to do is to discuss the results of this lab in terms of whether our results support the general motor ability hypothesis or the specificity of motor abilities hypotheses. So back to chapter 3, so you're going to find a little bit more information on general and specific motor abilities on pages 53 and 55 of your text. So the general motor ability hypothesis states that many different motor abilities within an individual are highly related. So if you're good at one test of balance, you should be good at all tests of balance. There's not a lot of experimental evidence to support this, yet it's still popular in the way, it's still a popular method of assessing individuals, right? So we have elders come in and we do a balance test. We may do one balance test. They fail it miserably, and suddenly, we say that, their balance is horrible and they need a walker or something like that. And so basically the general motor ability hypothesis, we're still using that testing method, and it's not evidence-based and it's not correct. What we really need is several different balance tests to really evaluate an individual and their motor ability, right? So that brings us to the specific motor abilities hypothesis, which says that many motor abilities in an individual are relatively independent. So you might be good at static balance, but not so good at dynamic balance, right? You might be great at underhand throwing, but not so great at overhand throwing, etc. And there is lots of evidence supporting this specific motor abilities hypotheses. So if you were to look back at our results and the correlation between just 3 static balance tests, which hypotheses would you support? And that's the crux of question 2. All right, so that is all I want you to do for this lab. And if you have any questions, please email me or see me in class.